Let us understand systems by taking a few common examples as we study the applications of Newton's laws of motion. So here is a horizontal surface on which a block has been kept. The block is currently stationary. There is no friction between the surfaces in contact. So as of now here there is no friction present. There is going to be a downward force of gravity. Because of gravity, the downward force on this block will be mg, wherein m is the mass of the block. Now there is going to be a counteracting force of normal reaction that is applied at the bottommost surface, but I am drawing it like this. So this is the force of normal reaction that acts in the upward direction. So if we are writing the y-axis equations of motion, then we'll get, considering the positive y direction to be the upward direction. So this happens to be the positive y direction and this happens to be the positive x direction. So for the y-axis equation of motion, we'll get n minus mg is equal to m into 0, because there is no motion in the y direction and hence acceleration in the y direction is 0. Therefore n is equal to mg. Similarly, writing down the x-axis equation of motion, we can have, if we apply a particular force, let's say F, in the horizontal direction, let us say this is the force F applied in the horizontal direction. So we can write down F, and there is no other force in the horizontal direction. So F is going to be equal to m into acceleration in the x direction. Therefore acceleration in the x direction can also be written as F divided by m. So this is a simple example wherein we have drawn the free body diagram. So this diagram is called as the free body diagram of the body, wherein we draw all the forces and analyze the accelerations in mutually perpendicular directions usually. Let's move on to a two-block system. So this is a system consisting of two blocks. So this is a block of mass, say m1, that has been kept on top of a block with mass m2. So the normal reaction forces will be as shown. On the small block of mass m1, the normal reaction in the upward direction will be n1, let us say. This n1 will also act on the block m2 in the downward direction. On the block m2, another force n2 will be acting on the upward direction, which is the normal reaction given by the floor on the block m2. Also, there is this force of gravity on the block m2, which is m2g, and of course there is a force of gravity on m1 as well, which is m1g. So considering only y direction equations and considering the fact that the blocks are not accelerating, they are currently at rest, we can write down for the block m1, we can write down n1 is equal to m1g, and for the block m2 we can write down n1 plus m2g is equal to n2. So this is the two equation two unknown system. m1g and m2g are known and the unknown parameters are n1 and n2. The value of n1 is automatically already found out using the first equation, and the value of n2 can be found out by substituting n1 that we have already obtained in the second equation. So we get m1g plus m2g is equal to n2, which makes complete sense and which we could have derived if we also had considered that this is the horizontal surface, and if we had considered these two blocks as one combined system, let us say it is one combined system like so, because it is not moving with respect to each other, we could have combined the system and we could have already said that normal reaction N2 that is exerted by the ground on this combined system N2, we could have also directly written it down as N2 is equal to M1 plus M2 G, because N2 is balancing out the weight of M1 and M2. Now this is a system wherein two blocks are kept in contact with each other. So there is a force F that we have applied, let us say, to the block of mass M1. So there is going to be a normal reaction force at this end. So let the normal reaction force be N. The normal reaction force, because of Newton's third law, will also act on the block of mass M2. So analyzing the two blocks separately, if we do a combined analysis, then we simply get F is going to be equal to M1 plus M2A, because these blocks, there is no friction. So in the horizontal direction, these blocks will move together. In the vertical direction, the normal reactions will cancel out the gravitational forces. So we are not writing down the vertical direction equation in this particular case. We are interested in the horizontal direction equation. So F is equal to M1 plus M2A will be the horizontal direction equation, which will give us A, which will imply A is equal to F upon M1 plus M2. Now if we do analyze the block M1 alone, then for the block M1 we can write down, this is the force F and this is the normal reaction N. So we can write down F minus N is equal to M1A. Similarly for the block N2 we can write down, for the block M2 we can write down the horizontal equation as N is equal to M2A. So we could have solved these two equations also to get the acceleration, or we could have used the logic about the combined bodies to directly get the acceleration. From these two equations also the acceleration is going to be equal to F upon M1 plus M2. And for finding out the normal reaction is N is equal to M2A. Therefore N is going to be equal to M2 times F upon M1 plus M2. So this is also obtained by solving these two equations. So from these also you can get N is equal to M2F upon M1 plus M2. Or you could just put this acceleration that you have obtained in here. Fine. So let's move on to a three block system, three blocks that have been kept in contact with each other. So this is M1, this is M2, this is M3. Let us say we are tasked with finding the normal reaction force over here, namely N1, which acts in between these two blocks. So N1 is acting on the block M1 as well as on the block M2, and the force, let us say N2 over here, which is acting in between the blocks 2 and 3. And of course there has to be an externally applied force F, otherwise these blocks will not move. There is no friction anywhere over here. So we can firstly find out the acceleration to be, considering all the three to be a combined system that moves together, the acceleration is going to be equal to F upon M1 plus M2 plus M3. This is going to be the acceleration. Now let us say we would like to find N2. The simplest way to find N2 is to analyze the block M3 on which the single force N2 is acting. So N2 is going to be equal to M3A, because m3 is also moving with the above mentioned acceleration a. So n2 is going to be equal to m3f upon m1 plus m2 plus m3. For finding n1, we can choose to analyze the block m1. So for n1, we can write down f minus n1 is equal to m1a. This particular equation is for the block 1. So f minus m1a is going to be equal to the normal reaction n1. So this is going to be equal to f minus m1 f upon m1 plus m2 plus m3. This is going to be n1. So after you simplify this, you will get this as m2 plus m3 into f upon m1 plus m2 plus m3. So this will be the value of n1. So this can also be concluded by considering m2 and m3 to be a combined mass m2 plus m3 that is being moved by the force n1. If we could have considered this, then the force n1 is directly moving m2 plus m3. So we could have directly written down n1 is equal to m2 plus m3 into a. We could have taken down the value of a over here from the above mentioned equation to get the value of n1.